Exercise 1.2, question 3. Find the LCM and HCF of the following integers by applying the prime factorization method. That means by just prime factorizing every number and then taking the prime factors with their greatest or smallest powers. We already discussed this in a lot of detail in question number 2. So I encourage you to watch that first, and then this question will be a breeze. Just for a refresher, HCF is when you prime factorize each number, then you take the product of the smallest power of each common prime factor. So first of all, you see which are the common prime factors, and then you take them with their smallest powers. While when you talk about the LCM, you take the greatest power in fact, and that too of each prime factor. So not just the common prime factors, but each prime factor. Let's just see, let's do this for part 1. You just have to prime factorize each number first of all. Let's bring it on a new screen. Perfect. When I prime factorize, these are very small numbers, so you don't really need the factor tree, but if you do, you can always use it. You will have 12 and 15 would be 3 times 5, and 21 would just be 3 times 7. Now let's write down the HCF first. So only the common prime factors. Let's highlight those common prime factors here throughout. Yeah, so they should be common to all three of them. You will just have 3 from here, here and here, not the 2. Let's remove that. Perfect. And then you take these common prime factors with their smallest powers. So when I see 3, the power here is 1, 1 and 1. It's anyway 1 in all three of them. So the smallest is also 1. So the HCF is 3 itself. Then when you think about the LCM, this time you take not just the common prime factors, you take each prime factor, and that too with the greatest power that it has. So each means I will have the 2 also, 3 also, 5 also, and the 7 also that I'm getting here in 21 with their greatest powers. So just put the greatest powers that you see throughout, and this is going to be the LCM. So when you multiply this, you get the LCM as 420. Now remember the result we talked about, that the product of the HCF and the LCM is equal to the product of the numbers. That is only valid when it's two numbers, not when it's more than two. So here you have three numbers. If you multiply these three numbers and if you multiply the HCF and the LCM, the product will not be the same. So do not try to extend that result here. Let's look at part 2 now. Since this is a direct replica of the previous question, not different at all, I encourage you to pause the video and try this yourself, and then resume and see the prime factorizations and the HCF and the LCM. Okay, if you tried, you would realize that all three of these numbers are anyway prime numbers. So the prime factorizations would just stay as it is. You cannot break them any further. So this was one piece, one different thing here as compared to part 1. Now if I see the HCF and the LCM, the rules are still the same. LCM takes each prime factor, so it will have 17, it will have 23 and 29, and every prime factor with its greatest power. But the power anyway is just 1. You don't have options, so you take them as it is. This product, which will give you 11,339, this is the LCM. HCF, you take just the common prime factors with their smallest powers, but there is no common prime factor. Each of them has different prime factors. So the HCF here really is 1. So you have nothing common. When you have nothing common, then there's always 1. Never say 0. That's a big trap. 0 is not a factor of any number, in fact, because you cannot divide by 0 only, while 1 is a factor of every single number. See, you can write each of them as 1 times, 1 times, and 1 times. So you'll see that the common factor that they have, the only common prime factor, not prime, the only common factor they have is the number 1. Let's now go to part 3. Alright, now the prime factorizations this time are also pretty simple. 8 is 2 to the power 3, 9 is 3 to the power 2, and 25 is 5 to the power 2. Yet again, let's just quickly write down everything. HCF takes only common prime factors, and I see nothing common among these three. So the HCF is going to be 1, very similar to what happened in part 2. LCM, on the other hand, will take each prime factor, so it will take 2, 3, and 5, and all of them will come with their greatest visible powers. Well, it's not about greatest and least because each prime factor comes just once. So you just have to multiply these and you will get 1800 as your LCM. And that's it.